Hello everyone, magandang buhay sa inyong lahat. Ang ating sesyon, ang ating pag-uusapan sa pagkakataong ito is all about moving loads. At syempre, ito naman ang inyong abang lingkod. Ngayon ay maaari na nating simulan ang ating diskusyon regarding about moving loads. Ano nga ba ang ibig sabihin ng moving loads? The bending moment under a particular load is actually a maximum when the center of the beam is midway between that load and under the resultant of all loads on the span. So, paano natin kaya mas maintindihan ang definition na yan? The maximum shearing force is equal to the reaction to the resultant load. Now, let us try to have a sample problem para mas maintindihan natin ang ibig ipaiwatig ng definition ng moving loads. A truck with axle loads of 40 kilonewtons and 60 kilonewtons on a wheelbase of 5-meter rolls across a 10-meter span. Compute the maximum bending moment and the maximum shearing force. Alam nyo ba na napakalaga ng moving loads concept sa pagdidesign ng mga bridges? Kasi sa mga bridges, dyan lagi mabibigat ang mga moving loads natin. So ito ngayon ang ating figure para sa ating problem number 1. Kung papansinin natin, meron tayong dalawang reaction for point A and point B. We have the R sub 1 and R sub 2 as our reactions. And then sa ating given B, meron tayong dalawang wheels or moving loads na 40 kilonewton and 60 kilonewtons. At the middle, makikita natin ang ating resultant force na mayroong total na 100 kilonewton. Nanggaling yan sa total ng 40 kilonewtons and 60 kilonewton. And so happen na ang resultant force natin ay nasa posisyon na 3 meters from point P and 2 meters before point Q. So, ibig sabihin, mamaya magkakaroon tayo ng iba't ibang mga center lines. Center line between point P and 100 kilonewton sa may 3 meter na interval, and then center line sa may 2 meters interval between the resultant force and the 60 kilonewton of point Q. Now, let us try to solve the problem. The start of our solution. With maximum moment under P. So, idodrawing muna natin ulit ang ating figure. Yan ang ating dalawang moving load na mayroong 40 kilonewtons and 60 kilonewton respectively. And at the middle, between them, we have the resultant force. Not actually middle kasi magkaiba ang layo, 3 meters dito and 2 meters naman before 60 kilonewton. Ito ang ating resultant force na mayroong 100 kilonewton na magnitude. And then ito naman ang ating center line. At dahil dyan ang ating center line, dahil may 3 meters siya, ang ibig sabihin, meron tayong mga distance na 1.5 and 1.5 meters each for a total of 3 meters. Dyan ang ating center line. Now, if this is 1.5, dahil 10 meter ang span ng ating beam, this will be 3.5. And if this is 2 meters plus 1.5, ang ibig sabihin, kailangan pa natin ng 1.5 meters sa right. So, for a total of 10 meters. Reaction 1 and reaction 2. Ito ang ating center line. So, let us write the points. Point A, point P, point Q, and point B. And then we have the reactions are R sub 1 and R sub 2. So with maximum moment under point P, we need to take summation moment at point A is equal to 0. Magmo-moment tayo around point A. And then let us assume that clockwise moment, positive. So this is going to be our equation because ang ating resultant force na 100 kilonewton ay may layo na 6.5 meters from point A at ang ating R sub 2 ay may layo naman na 10 meters from point A. Then we can now calculate for the reaction of R sub 2. R sub 2 is equal to 65 kilonewtons. And then let us take summation of forces vertical or y is equal to 0. R sub 1 plus R sub 2 minus 100 kilonewton, which is actually our resultant. And then we can now calculate for the value of R sub 1, which is equal to 35 kilonewtons. And then summation moment at P is equal to, or MP is equals to summation moment of left. MP is equal to R sub 1 X. Okay? So let us calculate now. MP is equals to 35 kilonewton dahil ang R sub 1 natin is 35 kilonewton at ang X natin is equal to 3.5. Okay? So MP now is 122.5 kilonewton meter. So let us proceed. With maximum moment under point Q naman tayo ngayon. Again, i-write natin ang ating figure. Now, ang 40 kilonewton ay may layo na 3 meters sa ating resultant force. Kanina, ang center line natin is nasa 3 meters. Ngayon naman is nasa 2 meters, although hindi lang nakascale ang ating drawing. Dahil 2 meters siya, na ibig sabihin may tigo 1 meter tayo na distances from center line to resultant and center line to 60 kilonewton ang ating point Q. Now, if this is 3 meters and that is 1 meter, kailangan pa natin ng 1 meter hanggang sa ating center line. If this is 1 meter, definitely this will be 4 meters after ng 60 kilonewton. So we have now our point A, point B, point Q, and point B. Again, we have the R sub 1 and R sub 2 as our reactions for a total of 10 meters ang ating span ng ating beam. Take note of this. If this is 10 meters, definitely this will be 4 meters. Kasi kailangan center line yan eh. 5 meters, then 5 meters. Talaga ang mga distances natin. Dapat ang center line is talagang nakasentro. So pag-aatiyan ng 5, ang 10 meters lang, tig pa 5 meters. So let us now calculate for our reactions, R sub 1 and R sub 2. First, we need to take moment at point A, summation moment at point A. Again, clockwise moment positive. Calculate na natin ang ating R sub 2. R sub 2 is equal to 40 kilonewton. And then again, summation forces vertical is equal to 0. We can now calculate for the value of R sub 1. Ang value ng ating R sub 1 is equal to 60 kilonewton. And then again, for MQ is equal to summation moment left. Okay, let us calculate it. So we have R sub 1x minus 100 kilonewton times 2 meters. So substitution tayo, ang value ng ating MQ is equal to 160 kilonewton meters. Next, thus our maximum moment is 160 kilonewton meter. Siyempre, pipiliin natin yung maximum talaga. Kanina kasi ang MP natin, kung babalikan natin ang ating computation kanina, ang value ng ating MP, let us see, is 122.5 kilonewton meter lang. Pero ngayon, ang value ng ating MQ is higher. So definitely, kung ano yung higher, yun ang ating maximum. So ang value ng ating MQ is equal to 160 kilonewton meter. So yan ngayon ang ating maximum moment. So kapag nagde-design tayo, lagi nating pinipili ang maximum moment. For maximum shear load naman, kung paano natin hahanapin, kung yan ang ating mga loading, ang ating moving loads, definitely, first step, yan, di ba yan ang ating mga points, point P and point Q. I-position natin ang ating mga moving loads sa pinaka-right, okay, sa pinakadulo. Yung ating wheel na 60 kilonewton, dapat ang position niya ay may posisyon sa pinaka-end ng ating span. Now, after na naiposisyon na natin ang nasa dulo ang ating wheel na 60 kilonewton sa right end ng ating beam, pagpatuloy na natin ang ating drawing. We have R sub 1 and R sub 2 for our reactions. And then, ang total length ng ating beam is 10 meters. We have the point A, point B, and point Q, and point B. Now, anong gagawin natin? Ano yung susunod na ating gagawin? Maximum reaction at B. So let us calculate. Summation moment at A is equal to 0 again. Clockwise moment positive. 100 kilonewton times 8 meters kasi ang layo ng ating resultant is 8 meters from point A. And then ang ating R sub 2 naman is 10 meters. Counterclockwise ang movement kaya negative ang sign ng ating R sub 2. If we're going to calculate for R sub 2, ang value natin is 80 kilonewtons. And then summation moment at y is equal to 0. Let us calculate for R sub 1. Ang value ng ating R sub 1, 20 kilonewton. So remember this, we have R sub 1 as 80 and R sub 2 as 80 kilonewtons. Coming up next, kung kanina sa pinakadulo ng right ng ating beam nating pinosisyon ng ating last wheel, naman ang ating unang wheel ay ipoposisyon naman natin sa pinaka-left ng ating beam. Yan. So, ganyan ang positioning. So, yung unang wheel na may 40 kilonewton, dapat ang position niya is nasa dulo ng ating beam, sa left. Sa left part ng ating beam, ng span ng ating beam. Okay, again. This is 60 kilonewton. Nakalimutan lang nating i-type. Okay. 60 kilonewton ang load na nasa point Q. So summation moment at A is equal to 0, clockwise moment positive. We can now calculate for R sub 2. Ang value ng ating R sub 2 is 30 kilonewton. And then afterward, pwede na natin calculate ang ating R sub 1 by summation versus vertical. R sub 1 plus R sub 2 minus 100 kilonewton. Ang value ng ating R sub 1, 70 kilonewton. So ngayon, we have 70 and 30. Kanina, I think we have 80 and 20 sa mga reactions natin. Now, ano ngayon ang ating maximum shear load? Ang ating maximum shear load is actually 80 kilonewton. So, syempre, pipiliin natin ang 80 kilonewton. In this given example, dalawa lang ang ating mga wheels, ang ating moving loads, na kung saan ay nakagitna ang ating resultant first. Now, let us try to have another problem. Kung kanina 2 wheels lang, ngayon 3 equal wheels tayo. 3 equal wheel loads of 30 kilonewton each separated by 2 meters between its load. Roll as a unit across the 12-meter span. Determine the maximum moment and maximum shear. And this is our figure. Ang ating beam, meron siyang 12-meter na span. And then, ang mga wheels natin, mayroong distansya sa bawat isa na 2 meters. We have the point O as 30 kilonewton and point P we have 30 kilonewton. Point Q of 30 kilonewton. And then, Sa magkabilang dulo ng ating beam, we have the point A and point B. We also have our reactions of R sub 1 and R sub 2. For the solution of our problem, let us start first with the maximum moment under point O. Again, this is the beam. So, pinili nating iposisyon ang ating center line sa pagitan ng point O and point P. Dahil 2 meters lang yan, syempre tigo 1 meter at nasa gitna ang ating center line. So kung center line yan, ibig sabihin 6 meter, 6 meter dapat ang atiyan ng span ng beam. So we have 5 plus 1, 6 meters. 1 plus 2 plus 3, we have 6 meters. So nasa center line na nga ang ating dalawang load, ang 30 kN na point O at ang point P kung saan nailagay ang ating resultant na 90 kN. Okay? So let's proceed. Again, summation moment at A is equal to 0, clockwise moment positive. We can now calculate for the value of R sub 2. Ang layo ng 90 kN sa point A is 7 meters because we have 5 plus 1 plus 1. And then ang R2 naman is 12 meters. Ang sign natin gagamitin is negative dahil ang rotation nito is counterclockwise. Ang R1 naman is, ang 90 kN naman is clockwise ang rotation. Okay? Ang R1 is hindi natin magagamit kasi coinciding ang line sa ating reaction sa point A. So we can now compute for R sub 2. R sub 2 is equals to 52.5 kilonewton. Then let us calculate for R sub 1, summation forces vertical. Ang value ng ating R sub 1, 37.5 kilonewton. And then for our MO is equal to summation moment left. MO is equals to 37.5 times 5 equal to 187.5 kilonewton meter. Now let's proceed. With maximum moment under P, point P will be at the midspan. So ibig sabihin ang ating center line nasa midspan talaga at nasa gitnang point. It is actually the point P. Now if this is our center line, okay, so if this is 2 meters, I think this will be 4. This is 2 meters, I think the other one is also 4 meters. For a total of 4 plus 2 plus 2 plus 4, we have 6 meters. Kasi nandito ang ating center line. Ibig sabihin, 66 meter ang portion na nandirito and then ang portion na nasa right. So let us take summation moment at A is equal to 0. And clockwise moment positive again. And then let us calculate for the value of R sub 2. Ang value ng ating R sub 2 is equal to 45 kilonewton. And then summation forces at Y or vertical forces at summation forces vertical or summation forces at Y is equal to 0. Pwede na natin kalkulain ang value ng ating R sub 1. R sub 1 is equal to 45 kilonewton. Okay, dahil symmetrical kasi yan kaya tig po 45 kilonewton lang ang dalawang reaction. Ang R sub 1 at ang R sub 2 na kapag pinagadaman natin, equal yan sa ating resultant na 90 kilonewtons. Then MP, summation moment, left. Let us calculate for MP. 45 kilonewton times 6. Ang ating R sub 1, imumultiply natin ng 6 meters. And then 30 kilonewton before the resultant na nasa point O, multiply naman natin ng 2 meters. MP is equal to 210 kilonewton. So ano ba ang ating MO kanina? Paki-remind lang natin, paki-recall. 187.5. So mas mataas ang MP. 210. Paano naman kaya ang MQ? So let us see. Ibig sabihin, magpapalit na naman tayo ng resultant first position or center line. Resultant first position and center line, I mean. So if this is R, 90 kilonewton, so dito ngayon ang ating center line sa susunod na akbang. So let us see para mas malinaw. With maximum moment under Q, so ito na ngayon ang ating center line. Tigo 1 meter. Okay, dahil 2 meters yan, 1 meter from point P to center line and 1 meter before point Q. So, ibig sabihin, kung 1 meter ito, kailangan natin ng 5. 1 plus 2 is 3, so kailangan pa natin ng 3 meters. Again, we can now calculate for R sub 2 by taking moment at point A or summation moment at A is equal to 0, clockwise moment positive. So, calculate na natin ang ating R sub 2. 90 times 5 minus R sub 2 times 12 is equal to 0. Ang value ng ating R sub 2 is 37.5 kilonewton. And then, summation forces vertical. R sub 1 plus R sub 2 minus 90 kilonewton is equal to 0. Ang value ng ating R sub 1, 52.5 kilonewton. And then, try na natin i-calculate kayo ng ating MQ equal to summation M, left, from left. MQ is equal to 52.5 times 7. Dahil ang R1 is 52.5, multiply natin yan ng 7. Okay? Hanggang dun kasi 7. 3 plus 2 plus 1 plus 1. And then 90 times 2. Okay? 90 times 2. Ito kasi yung 90 natin, 1 plus 1 is 2. So MQ is 187.5 kilonewton meter. Then let us have now our maximum shear load. Same process, dulo sa dulo yan. At point B, yan. Ang pinaka-last wheel natin, dadalhin natin sa pinakadulo. And then, summation moment at A tayo is equal to 0. Clockwise moment positive. Calculate natin ang ating R sub 2. We have 75 kilonewton. And then afterwards, summation forces vertical is equal to 0. We can now calculate for R sub 1. Ang value ng ating R sub 1 is simply equal to 15 kilonewton. The next, at point A, siyempre, ang 30 kilonewton naman ng point O ang dadalhin natin sa dulo ng left ng ating beam, ng span ng ating beam. And then, same procedure. Let us calculate for the reactions. Summation moment at A is equal to 0, clockwise moment positive. 90 kilonewton times 2 minus R sub 2 times 12 is equal to 0. Ang value ng ating R sub 2 is equal to 15 kilonewtons. And then, summation forces vertical is equal to 0. R sub 1 plus R sub 2 minus 90 kilonewton is equal to 0. Ang value ng ating R sub 1, 75 kilonewtons. Thus, the maximum shear load is 75 kilonewton. Bakit? Ano ba yung kanina? Bakit 75 kilonewton? Kanina kasi, we only have, pareho lang. We have 75 and 15. And then sa point A, kung ipagpapatuloy natin yan, makikita natin 75 and 15 din. So talagang ang ating maximum shear load is equal to 75 kilonewton. At syempre, walang duda ang ating maximum moment ay yung pinakamataas kanina sa point P, ang MP natin na equal sa 210 kilonewton meter. So yan ang ating mga sagot, ang ating maximum shear load at ang maximum moment na 210 kilonewton meter when P is at midspan. So yan ang mga data na ating kakailanganin kung tayo ay magde-design ng structure, ng structural member. For your exercises, pakisolve ang mga sumusunod. For problem number 1, Three equal wheel loads of 40 kilonewton each separated by 3 meters between each load roll as a unit across the 12-meter span. Determine the maximum moment and maximum shear. Okay, so this is going to be our problem number one for your exercises. And then problem number two, a track with axle loads of 45 kilonewton and 55 kilonewton on a wheelbase of 5-meter rolls across a 10-meter span. Compute the maximum bending moment and the maximum shearing force. At syempre, ito ang ating figure na inyong i-analyze. So, pakihanap na lamang ang maximum bending moment and maximum shearing force or shear load ng ating problem number 1 and problem number 2. Hanggang dito na lamang. Maraming salamat po and God bless us all. Thank you very much.